Fog hangs low over RAF Ridgewell on February 8, 1942, a grey sheet that swallows sound and leaves only the soft, insistent drip of thawing frost. In that white hush, a Lancaster BI 1234 sits like a corpse on the mud, its skin torn in places, canvas flaps fluttering where men fled, and its tail is a splintered geometry pointing at the low sky. The bomb bay yawns empty as a jaw, the release mechanisms slack and oil-stained, and the merlins along its wing sit quiet, their V-12 throats cooling into a dull, oily hush that smells of petrol and yesterday's thunder. Edward Chamberlain of the Times walks the perimeter with a notebook, his breath a small cloud, and his pen moves with a reporter's hunger. This is not merely a wreck, he writes. It is a message left in metal and mud. Bootprints smear the clay toward the fuselage, the hurried spoor of crew who left with eyes on the horizon. A sentry paces and his breath makes small ghosts in the air while he stares at the empty turrets. Inside the cockpit, instruments glare blind. Broken needles frozen at last readings, caps popped from knobs, radios dark. And the pilot's seat bears the faint outline of departure in a greasy silhouette. Hydraulic lines hang limp beneath the belly like severed veins, their fittings glinting with a cold patina, and crimped copper terminals in a cut loom shine faintly where panels ripped away. The Browning 303 mounts in the nose and dorsal turret sit like mute sentinels, barrels cold and pellets missing, testimony to a fight that stopped halfway through its sentence. The field is a study in absence and evidence. The hush lets small details speak loud. Frost cracks on rivet heads, and a mechanic's rag is left twined over a maintenance bracket, as if someone shrugged and went. Men who know metal and its moods kneel and touch the skin, the drum of a rivet, the give of a doubler plate, and read the aircraft like a ledger of blows. Look at the crimps here, a foreman mutters, fingers on a terminal that shows neat, repeated crimps. Someone else notes uniform fittings stamped with supplier codes, small codes that mean system and repeatability more than art. The Lancaster's Merlin power plants are a study of engines and craft. Cowlings are ajar, and mechanics peer at rows of pushrods and tappets, the great rods that translate crank to song. The supercharger housings sit dark and patient, carburetor linkages dumb but intact, prop hubs marked with torque stamps. A soft wind lifts the edge of a leading edge panel, revealing a pattern of fasteners laid out with a logic that whispers of jigs and templates. These are not random repairs. The holes and the edge treatments show intentionality, the work of an industrial hand used to repeat and measure. Chamberlain writes phrases that will sting cabinet rooms later. A system more than a machine, he scribbles, and his voice on the air becomes the echo of a nation hearing itself. The airfield wears its weather like an old coat, and men move in the rhythm of small checks. Bolts counted, oil stains circled, a clipboard ticked to quiet the mind. A corporal lifts a drip pan and finds hydraulic residue the colour of tea. Notes that the lines were pressurised recently, and the implication is sharp. Men left in haste with systems hot and dangerous. That haste is a human scar written on metal. Word moves fast up the chain. By March, engineers from Boscombe Down and the Royal Aircraft Establishment are driving across county roads toward Ridgewell with toolboxes and measuring instruments. Group Captain Arthur Griffiths assembles a narrow team. Marsh, Collins, Bishop, Harding, men who will read metal like scripture and write reports in numbers that change strategy. They bend over the Lancaster and set out micrometers, feeler gauges and calipers as if they were priests with liturgical instruments. Every measurement is a question answered. How was this machine made, and what does that answer mean about the enemy who flew it? The teardown is methodical and wrenched with a kind of reverence. Panels come away to reveal wiring looms neat with crimps, terminals swagged and labelled with commercial codes. Electricians gape at the use of modular plugs, where British practice still favours hand-soldered terminals. Engineers find evidence of automated reamers and earlier stamping dies. The hole patterns are symmetrical to an almost clinical degree. They measure what we fit by eye, one mechanic says of home practice, and a young engineer, William Harding, records the variance in rivet heads down to thousandths, a number that tastes like revelation on his tongue. The Merlins are pulled and opened, pistons removed and scored, camshafts checked against charts and blueprints that only a handful of men possess. Charles Edwards examines crankcase mating faces and marks tolerances that would have been a god to any artisan fitter. The superchargers show machining marks and serials that point to mass processes, and in the turbine housings, there is evidence of attempts, some crude, some near correct, to integrate turbocharger systems. The team notes not just parts, but the forensic life of an industry, supply stamps, batch numbers, the fingerprints of production lines. They move the hulks and parts to the RA at Farnborough, where the work can be done under heat and lights, and in May and June of 1943, the first restored Lancasters roll onto flight lines like trophies of industrial inquiry. Pilots named Foster and Green climb into cockpits once enemy, now interrogated by British hands, and they feel the machine breathe under them. Radio chatter translates into measured praise and a chill respect. The Lancaster's structure holds hits that would upset lesser designs. Its modular fittings allow field repairs that get a bomber back to service at astonishing speed. The flight tests give numbers to the ore, payload, endurance, climb with 4 Merlins turning a precise, patient thrust. Public sensation follows the test reports. The Times runs an anatomy piece, and Chamberlain's dispatches stitch public interest to technical insight. The image of British engineers prying open an enemy bomber becomes a symbol of turning tables, a captured design as teacher rather than conqueror. Yet the technicians in the sheds do not gloat. They carry a professional unease. What they measure is not just craftsmanship, but a systemic organization that the enemy has made manifest in metal and jigs. Beyond the instruments and pressings lies strategy, and the auditors realize that copying a blueprint is a pale victory, unless anchored in factories, tooling, and suppliers who know rhythm. Sir Alan Brooke and others sum the shame and the lesson. Production system matters as much as design. The Japanese and German attempts to lift designs without systems show that a drawing does not equal dominance if the means of production are absent. The team's reports begin to read like a manifesto. This war is industrial arithmetic as much as it is heroism. Test flights also reveal the human cost of robustness. Engines that keep spinning under fire cost lives in the sense that crews expect to be recovered. But the enemy who faces a resilient bomber finds attrition a long hammer. Cinematographers film operational trials, and the public sees a machine that is stubborn where the war had hoped for fragility. The Luftwaffe's planners and the German press misread some images, and later intelligence reads their confusion. Photographs from Farnborough turn into rumours of a Type A bomber in captured reports. Even enemy disbelief becomes evidence of the psychological reach of industrial capacity. The audit's volumetric measures, tolerances, rivet patterns, terminal crimps, tell of an industrial culture oriented to repeatability, to stamping and jigs and automated drilling. Where British shops prize the skill of the fitter, the Lancaster suggests a workflow of interchangeable parts and supplier chains that favour speed. The RA notes read like a recipe: jigs here, dies there, supplier integration as sinew. The implication: victory will belong to those who can match design with repeatable process. The conclusion is not immediate triumph, but a sober strategy shift. Britain marshals the lesson into post-war plans for modernisation of Hatfield and Filton. Young engineers trained at Farnborough will carry the Lancaster case into peacetime industry. The war's last years see production systems increasingly optimised, and the post-war decades find British aerospace reborn in methods coaxed from a captured bomber. The RA's notebooks become textbooks and lectures in university halls. Rivet tolerances measured in a muddy field are taught as doctrine to a new generation. Still, there is a human note that endures. The men who stood knee-deep in mud at Ridgewell, foremen with hands like ploughs and pilots who once saw the Lancaster as enemy, carry a quieter knowledge home. Machines are made by men, and men can remold systems that once threatened them. At night, in messes, they whisper about rivets and jigs and the odd poetry of a serial number on a part that told them the enemy's supplier. A young mechanic will later boast he worked on a crankcase that once flew under foreign colours. He will say it with a mixture of humility and hard pride. In a hangar at Farnborough, the last footage is catalogued, and a clipboard with Griffith's notes rests against a maintenance stand. A Lancaster under soft museum light will later look dignified, its merlins silent like old beasts finally sheathed. Edward Chamberlain's notebook finds a place in archives, and the public reads of the day thunder stilled, and the machine taught its captors a lesson in scale. The final line of the report lingers like a verdict. In total war, organization is the sword and the saw, and a single plane, broken and abandoned, became a teacher that remade industry and strategy. Fog eats the morning at Ridgewell, and the first task is counting wrecks as if they were bodies in a ledger. Each lance's silhouette is a problem that will not speak until hands give it voice again. Men from nearby units and civilian contractors move like a slow tide across sodden fields, finding torn control runs and half-cold merlins that still smell of burnt oil and last night's thunder. A crane groans and sets a wing down with the tenderness of a surgeon. Group Captain Arthur Griffiths stands in a soaked leather coat and watches as scribes mark serials and tag parts, his breath a white line in the air. He says only, "We will learn from what they left," and the team hears both promise and duty. The physical scene is brutal and poetic. Frost on rivets, mud filling footsteps, gun turrets frozen mid-sight, hydraulic pipes dangling like broken veins. This is not salvage for scrap. It is evidence to be read, measured, and converted into knowledge before winter erases the signs. They catalogue each machine by number, by damage, by the language of collars and stamps. CN, serial, squadron codes picked off like splinters. Local boys climb into cockpits and retrieve logbooks splayed with ink. And a navigator's map with rounds punched through it becomes as holy as any relic. Engineers from Boscombe Down take out micrometers and calipers, and there is a small, fierce hush as they measure rivet spacing and panel tolerances. Charles Edwards notes a pattern of identical crimps on electrical terminals and writes it down twice. A de Havilland Dragon. Rapide huffs in to fetch small parts and men, its fabric wings trembling as if it shares the cold. Larger pieces go by lorry, wing sections strapped like coffins onto flatbeds, while convoy drivers pray the roads hold. Mechanics, the old breed who speak in valve clearances and spark timings, walk the airframes and laugh with a gravely delight when they find a patch that will bolt straight on. Interchangeability in the field is a small revelation that tastes like victory. The work is improvisation under pressure, and it smells of grease and strong tea. Panels are cut from one wreck and grafted onto the next, a cannibal's grace that makes machines whole. "Pass that doubler here," a foreman orders, his voice a saw as men lift steel and fit. Hydraulic manifolds that were ripped are refashioned with fittings scavenged from trucks and tractors, hoses braided, clamps adapted, until a system will hold pressure and not weep. Electrical looms are painstakingly rewired using crimped terminals where solder once might have been used, a concession to speed without giving up safety. An electrician hums as he crimps, feeling the firmness of a good joint like a prayer. The Merlin V12s are crated and rolled to temporary benches, where cylinder heads are photographed, pistons measured, valve seats checked. Every thrum and scratch is a clue in an aircraft's life. Long nights at Boscombe Down become a liturgy of repair. Men huddle over engine stands with torches and cigarette ash, turning over camshafts and checking supercharger housings for signs of heat crazing. One mechanic, fingers stained black, whistles a tuneless song and says to his mate, "If she starts, she sings like a cathedral," and the others nod with a small, tired grin. They lap bearings, hone bores, and chase oil leaks until tolerances read true. Pistons are weighed to the gram, and crank journals smoked and polished until the run-in is right. Test benches hum with the slow, patient music of two-stroke loads and prop spindle torque. Every signed-off engine is a promise that the plane can breathe again. These are not showrooms. They are the back rooms where continuity is forged. When the first restored Lancaster rolls to a makeshift flight line, the ground seems to hold its breath. Tractors tug skins taut, men do last checks on tailplane trim and bomb release mechanisms, and wings are swept clean of mud. Squadron leader Robert Green climbs in, the headset heavy, The instruments a familiar but foreign face, and his fingers find the throttle like a second language. "Ready on the line," someone calls. The propellers wind, Merlin's cough, and for a moment the whole machine trembles between death and life. That first taxi is a sermon. Speed picks up, rudder corrects, and the Lancaster breathes as a machine remade by will. The pilot radios up with a voice that tightens and then lets go. "She flies," he says, and a cheer rolls like distant thunder. Organising ferry flights to Farnborough becomes a campaign of logistics that reads like a map of devotion. De Havilland Dragon Rapides, ferry spare panels and avionics, flatbeds roll slow and careful, and the team coordinates fuel stops, escorts and radio checks across counties. Griffiths draws a line on a chart from Ridgewell to Boscombe Down, and then to Farnborough. Each segment is a puzzle. Range, weight, enemy action, weather, and each solved problem is a small miracle. The restored Lancasters do not travel alone. They fly with escorts, with de Havilland transports as motherships, and with careful radio silence punctuated by scheduled contact. Pilots monitor manifold pressure and manifold boost settings, as if reading a lover's heartbeat, and the Merlins reply with a steady, deep pulse that makes men's hands steady. The ferry flights in May and June of 1943 carve a new geography in the sky. Lancasters that had been husks now span the map from East Anglia to Farnborough. Their crews a mix of RAF test pilots and mechanics who know these machines from the underbelly up. Engines spool and climb, and men count fuel by cadence, minutes of RPM and manifold reading, because the cargo is not only metal, but intelligence. Turret guns are taped down, bomb racks carried as ballast, and each landing in Farnborough is a small triumph shouted across the field by men who have been building a choir of metal. "Touchdown smooth," a pilot says into the radio, and the ground answers with a practiced readiness to catch this taut bird. At Farnborough, the cleaned Lancasters enter an even colder, more clinical world, where the Royal Aircraft Establishment peels back skin and writes long reports. The teams of Griffiths, Marsh and Bishop set up calibration rigs and measurement benches under electric light. They measure rivet patterns, drill jig marks, and compare stamping dies to see whether holes repeat with machine-made precision. "Look at this," Harding says, tapping a drawing. "These holes are drilled by jig in a way our workshops only dream." The discovery is not merely technical, it's philosophical. Here is evidence of system, of supplier chains and quality control that go beyond good hands and into industrial choreography. Engineers find modularity in harnesses and plugs that speed replacement, and the electrical crime of crimped terminals puzzles British technicians used to hand-soldered joints. The Americans and their suppliers had embraced methods that let an airframe be fixed quicker than a craftsman's patience. The hydraulic fittings are stamped with supplier codes and pressure ratings, and the manifold layout whispers of production lines where each worker fits a piece and the whole fits without argument. These discoveries are catalogued not for bragging, but for survival. Griffiths knows that to copy a drawing without copying the process is to build a beautiful lie. The RAE begins to map not just a plane, but a manufacturing philosophy that produces machines in fleets. Months of work grind into data and then into doctrine. The charts from Farnborough are folded into briefing books and shared with ministers and factory bosses. The nation hears about aircraft reborn from enemy fields and the public exults, but in the white rooms of the RAE, the talk is of jigs, dies and supplier networks. "Design is nothing without repeatability," Griffiths tells a room of planners, and the sentence sits heavy and true. The wartime urgency translates into a plan. Post-war Britain must learn to make not single marvels, but fleets with welded consistency and measured tolerances. Test pilots who flew a Lancaster once enemy now teach RAF crews to read its temper and its strengths. Wing Commander Foster briefs young pilots on fuel margins and bomb release quirks, and his voice has the calm of a man who has seen a machine die and then come back. "She carries real punishment," he tells them, pointing to diagrams of redundant spars and bulwark panels. "But remember, she is also a manifest of industry." Students scribble numbers and the names of suppliers. The classroom feels like both cathedral and factory. The learning is precise and urgent. A rivet pattern equals a repair time equals a mission's survival odds. The moral charge of flying an enemy machine under British insignia is heavy in the cockpits. Some pilots feel an odd respect, and others a flush of defiance. "We fly their ghost now," one mechanic says, half in awe, half in jest, as he tightens a torque nut on a prop hub. There is an odd intimacy in that defiance. Men repairing what once killed them. And the intimacy becomes a teacher. The Lancaster, once a voice of the night enemy, now speaks in English avionics and British gauges, telling lessons men will not forget. When news of the restorations reaches wider intelligence circles and even foreign cameras, rumours grow. Farnborough Type A whispers in enemy logs. Yet the true story is quieter and more dangerous. The return of machines taught that industry shapes strategy. German reconnaissance photographs that later capture Lancasters at Farnborough are annotated with bewilderment. Their analysts write in margins, "Unexpected presence." The psychological effect is as meaningful as the technical insight. Seeing an enemy machine reborn on home soil rewrites assumptions about reach and resilience. In the long months, the restoration project becomes a mirror held to Britain's own industrial limits and promises. Workshops at Hatfield, Filton and Manchester begin to revise jigs and invest in the automation that seemed alien in that mud. Engineers who learn from the Lancaster's stamped panels teach apprentices new rhythms: drill, pry, measure, stamp, with a practical zeal. The country's post-war reconstruction will carry the imprint of those lessons, and companies that once made fixtures for wartime aircraft will later make the machines of peace. The Lancaster's second life is a seed. The final ferry into Farnborough is a quiet triumph and a cliff that opens into deeper work. The machines rest under lights, and the RAE's notebooks fill with numbers and questions that will feed decades of engineering. Griffiths pins a final report to a board and looks at men who have turned mud into knowledge, who have moved brute wreckage into reason. He says softly, "We dragged a giant home and learned from its bones." And the statement is both humble and vast. The arrival at Farnborough promises the audit to have its say. Industry, not ingenuity alone, will decide the next chapter of air power. The hangar at Farnborough smells of oil and hot metal and old paper, and under the electric lights, a Lancaster lies open like a patient on a slab. Men in wool coats bend and peer, breath fogging in the cold, and the first sound is the click of a micrometer as Flight Lieutenant John Marsh measures a rivet head to a whisper of millimeters. The micrometer speaks in tiny clicks, and the number appears on a brass face, and the auditors lean close like students learning a new alphabet. William Harding makes a dry note and fingers a pattern of holes, and even the pens seem to hush in respect. This is not a scrap heap, it is a ledger of choices etched in skin and steel. They strip the outer skins with soft, careful hands and reveal a lattice of stampings beneath, and the stamped panels are identical in a way that stuns the eye. "Same pattern, same die," Henry Collins says, tapping a panel. The stamping marks repeat like seam lines on a great garment, no tailor's improvisation, but a press doing what presses do best. Men hold panels side by side and see the truth. These pieces are made to fit without a craftsman's final touch. The revelation is quiet and sharp. Repeatable parts mean repeatable planes. Electricians crawl into the belly and lift looms like snakes, and their fingers find crimps instead of soldered joins at nearly every junction. Thomas Bishop runs a terminal with a thumb and announces the find like a verdict. Crimped copper every time. The crimps are neat, uniform, factory-made, and they promise rapid replacement in the field rather than long bench repairs. A wire harness labelled with supplier codes peels away, and the team traces each tag back through a chain of vendors, thinking in terms of supply and not of singular genius. The engineers sense a system hiding inside a single machine. Hydraulic manifolds come next, heavy with fittings stamped by codes that answer like telephone numbers to depot men. They test each fitting against a standard Titan jaws and find tolerance marks stamped on the flanges, proof that pressure tables were obeyed at the foundry. A manifold that can be unbolted and swapped in the field is worth whole days of survival for a crew. and the men catalogue these small allowances with grim approval. Standardization, they learn, is not sentimental. It is survival mathematics. The Lancaster's plumbing reads like a manual for fast repair. They cut through cowling and lay bare the Rolls-Royce Merlin V12 in a frame that looks like an engine and a cathedral at once, and Charles Edwards calls for a hoist. Pistons come out ringed in soot and etched with mileage, camshafts show wear patterns, and supercharger housings reveal machining marks that are not random but stamped by the lathe. The team photographs each mark, measures each bore, and the data fills notebooks that smell of oil. "Look at this finish," Edwards says, pointing at the compressor wheel seating, and the others nod because a finish like that is not artisan luck but machining discipline. They weigh and note each propeller hub, and the tolerance sheets slide across a bench where measurements are argued to the thousandth of an inch. The hubs are not hand-fitted anomalies. They are numeric truths, bosomed in charts and torque stamps. 0.002, Harding reads aloud, and the room hears the number as a bell. Precision like this in a war machine is more than craft. It is a promise that another man, another field, another hand will find the part and let it fit. Repeatability is written here as law. Files rasp and calipers whisper as panel edges are deburred and test holes are checked against a drilled jig. The auditors trace the nesting of holes and realize the pattern is a drill line from a machine, not an eye. Automated riveting jigs have left their ghosts. Dimples, uniform countersinks, and rivet shanks consistent in length and head profile. Men who have spent years coaxing parts into place stand back and feel the meaning. Where a skilled fitter once made a plane unique, a jig makes many identical. The machine of war favors the machine that makes machines. In a corner, a bench holds a gearbox stripped of its hydraulic pump, and the teeth on the gears show an evenness that speaks of gear grinders and indexed cuts. The gearbox is a chorus of metal, each tooth singing with the note of a machine that has been made to mesh without fuss. "You don't tune that by feel," Marsh says, and he sounds both proud and humbled. They measure backlash to a whisper and mark the numbers down. These digits will travel back to policy rooms and find their way into decisions about factories, not flight manuals. The auditors pull panels to find press-formed doublers and stringers, plates formed in dies rather than hammered to shape, and the press's fingerprints are visible in the metal grain. These doublers are not badges of luxury, but statements of intent, strength delivered at scale. Bishop runs a file along a seam and smiles like a man who has read a secret in plain type. The Lancaster's skeleton is an instruction book for how to build not one plane, but 1,000. They unpack supplier stamps and call up names of firms that sound like towns and rivers, and this web of vendors unrolls into a lattice of industry. Presses in Michigan-like yards, foundries with ovens tuned to precise metallurgy, and machine shops with jigs that bite metal the same way every time. The team draws a map not of design, but of production, supply arcs, supplier nodes, and time flows. It dawns on them, this is an economic architecture, not merely an engineering one. The machine is an organism of industry. At the bench, a young technician removes a Browning 303 mount and finds mounting points with repeatable nut plates and uniformly spaced rivets. Defensive armament is thus made to be swapped with speed. Gunnery fittings are standardized, so a depot can replace a ring mount in hours, not days. That agility is a force multiplier under fire. The pilot's chance of survival climbs not only with gunnery skill, but with the system's ability to mend the wounded. The auditors write that down like a line from a prayer. By dusk, the pile of data is a mountain. Charts, photographs, talk sheets, supplier lists. And Griffiths stands over it, like a man looking at a map of a future battle. He sees a single truth emerge in brass and ink. Copying drawings is folly without copying the factory that made them. We can reproduce parts, he says, voice low, but can we reproduce the river that feeds the mill? The room hums with the weight of that question. Strategy and industry meet in the silence. The final act is clinical but reverent. The wreck is not merely measured, but taught to those who will teach others. Reports take shape with appendices, full of numbers to be read in ministry rooms and factory floors alike. The auditors close notebooks with a sober clarity. The Lancaster is not a solitary genius, but an index of a system that can be learned or resisted. They leave the machine on its stands, its skin open to light, a lesson waiting in metal. Outside the hangar, the fog has thinned, and the world feels colder for the knowledge gained. The men step into air that is different because a secret has been pried open. The machine, measured and catalogued, has become a mirror showing the shape of industrial power. Griffiths walks slowly away with the soft clack of micrometers in his head, knowing the next fight will be fought not only with courage in the air, but with jigs and supply chains on the ground. The cliff hangs open. A single plane yields a philosophy, and with that philosophy, the war's axis subtly shifts. The first climb felt like confession. Wing Commander Michael Foster eased the throttles forward, and the 4 Rolls-Royce Merlins under the Lancaster's cowl answered with a deep, synchronized burble that went through his bones like an old hymn, and the huge airframe shrugged off mud memories as if waking. In the cockpit, the dials glowed dim and familiar. Manifold pressure, oil temp, boost, and Foster's gloved hand read them like a man reading a friend's pulse. Outside, Squadron Leader Robert Green listened to the autopilot trim click, felt the tiny corrections that keep a heavy bird steady, and tasted the cold high air through a slightly cracked canopy. For a moment, the bomber was simply metal and rhythm, and the long months of hammers and late lamps fell away into pure flying. They ran the envelope with a careful cruelty. Flaps in, flaps out. Bomb shackle toggles cycled until the gear teeth hummed, and each movement was noted with pen and quiet voice. The bomb bay doors breathed open like a beast exhaling. Mechanisms that had been welded and welded again replied with a precise, clinical clack. Foster called out speeds and rates, indicated airspeed, climb rate, prop pitch, and Green answered with trimmed notes on stability and yaw tendencies. The Lancaster did not charm with agility. It answered with steadiness. And steadiness in this instrument meant endurance when the sky was a storm of fire. Gunnery trials came like a darker lesson. They rigged Browning 303 mounts and fired ranges of tracer into drogue sleeves, watching the spray stitch the air and the turret's traverse motors take the load. The dorsal ring and tail turrets turned with a hungry torque, and their feeds did not choke. Barrels warmed and the smell of burned cordite stitched into the cockpits like a warning and a proof. Men in turrets called correction vectors and noted recoil effects on sighting lines. The practice showed that a concentration of defensive arcs could blunt an attacker's greed. The bird's skin took simulated hits, and under those bangs, the structure kept its geometry like a man who will not give ground. Back on the ground, the technicians measured what the eyes had just seen. Engineers crawled with feeler gauges and micrometers, recording deflections after live fire models and noting where quick change fittings let a mechanic swap a critical unit in hours, not days. A hydraulic manifold, unbolted and replaced, stopped a leak that would have grounded a squadron. A crimped terminal in an electrical loom saved wiring time by a technician's minute. Those minutes add up to sorties, and sorties accumulate into pressure on an enemy that cannot match the supply chain. Foster's log filled with both flight data and small, delighted exclamations about how fast depot fixes could return a warbird to the line. They staged simulated damage and watched how the Lancaster absorbed punishment. Hit a spar here, cut a control run there. Each trial produced data, not drama, and the machine's redundant paths and doublers held shape where lesser frames would bend. Green felt a faint reverberation through the stick and knew where the stress concentrated. He spoke in clipped tones. Hold the attitude, feed the trim, and the machine obeyed. That obedience felt like a moral, designed for repair, and a nation can afford endurance. The team catalogued a dozen such instances, each a small argument against the myth of singular heroism in the air. Word of the tests found paper and voice. Edward Chamberlain at the Times walked the flight line and wrote a piece that clipped into public conversation, an anatomy of the enemy's bomber that ringed the morning and sent readers into a studied panic and pride. The public loved the idea that a captured enemy machine could be made to teach them their own strengths. Editors loved the spectacle of an adversary turned tutor. Yet while headlines sparked pride, the engineers in hangars kept tally with cranked hands, knowing the longer truth. A machine taught them method as much as design. The article fed morale, but it also fed a sober debate in rooms where ministers read notes and planners folded in new tables. Across the channel, intelligence watchers flinched and misread the lesson. Reconnaissance photos of Farnborough, showing Lancasters under light, were scribbled over and circulated with the legend, ambiguous, nervous, of a new bomber type, a Farnborough Type A. German analysts murmured in diaries and margins, impossible range, uncanny resilience. The psychology of seeing a massive bomber intact on enemy soil had a sting. It suggested not that one plane had been spared, but that an adversary could take, study, and then outmanufacture lessons into power. The rumour fed fear where the facts fed strategy. The RAF's own pilots felt the shift beneath their gloves. Foster and Green returned to briefings with a new vocabulary: redundancy, interchangeability, depot turn time. The coffee-stained charts in the briefing room now included columns for repair time and supplier code, because they had learned that a plane that can be fixed quickly is more lethal than a plane that is merely sleek. "We don't just add hours to a sortie," Green said once, voice low. "We add resilience to our whole operation." That resilience, quietly tabulated, turned sorties into campaigns that could not easily be undone by single victories. Propaganda reels showed sleek shots of Lancasters rolling under Farnborough lights, the camera loving the symmetry, the public lapping up the recovery tale. But Foster and his fellows knew the reels were a gloss over a deeper engineering narrative. The cameras could not show the sweat in the back rooms, the long nights at Boscombe Down, the sequence of test fittings and reams of supply invoices. They could not show the engineers' private, almost religious thrill at finding a supplier stamp inside a manifold. That stamp was a cipher revealing the logistics behind victory. And logistics, they realized, is a brutal kind of poetry. Field reports began to change tactics. Bomber command planners, supplied now with data on repair curves and recovery timetables, adjusted mission depths and confidence bands. Where once the margin of loss was tolerated, now it could be calculated and reduced. Flights to industrial heartlands became straighter, more frequent, and held a new weight. Endurance backed by factories. The men who hung the maps in the ops rooms used this data as a shield for crews, and relief was visible in faces that had once worn the tight lines of constant dread. Yet the Germans learned too, and the rumour of a Type A pushed them into anxious innovation, diverting resources in fruitless directions. Their reports, sometimes shrill, sometimes clinical and occasionally honest, spoke of a capacity they could not match without reshaping their industry. The operational advantage conferred by repairable fleets and fast depot response had an unseen echo, an enemy scrambling to redraw its own production calculus. Psychological warfare merged with industrial arithmetic. On a test sortie, a Browning belt jammed in a simulated intercept and a turret mechanic shouted into the headset. The crew paused, hands were steady, and the Lancaster kept flying because redundancy let it. That minute of potential catastrophe taught a pilot a larger law. A flock that can heal itself will outlast a sword that cannot be resharpened. Foster felt the lesson in his bones, a slow and stubborn truth. Metal without systems is brittle, and men without supply are hopeful at best. Engineers took the data and fed it into slides and reports. In committees, they argued about jigs and dies and the feasibility of mass production. But for the pilots, the mathematics translated into something more immediate, a higher chance to bring men home. "Fixable," Green said once, slapping a panel whose stamping matched a die template. "That word keeps my hands from trembling." The quiet gratitude in his voice was the same gratitude a soldier feels toward a medic. Work that saves lives by small, precise acts. Industry answered. Workshops that had lingered on artisan technique began to hum with new urgency. Presses were ordered, suppliers integrated, and the pipeline, slow and brittle before, learned to loop. It was not quick, and it cost nights and money, but where the Lancaster had taught the shape of mass repair, Industry learned to beat in that rhythm. The RA's notebooks filled with action items, and the Ministry of Aircraft Production drafted new orders with a steady hand. The centrifugal effect of those changes reached battle planning in ways few had guessed. An air campaign is not only about bombs and pilots. It is a ledger of parts, entry times, depot cycles, and supplier fidelity. The Lancaster's endurance showed war planners that attrition could be turned into a number you manage if you can manage the supply. That number became the fulcrum on which strategy tilted. It was arithmetic more than heroics that began to close maps. When Foster and Green finally sat in the mess after a long day of trials, they spoke in softer tones about men who do the quiet work. They build the thing that keeps us flying, Green said, pointing to a grease-blackened hand. We drop bombs. They keep the planes. There was no glamour in that statement, only the blunt truth that a war's outcome hinges on the patient, invisible labor of repair and repetition. In the logbooks and in the public papers, the tale of the recovered Lancaster rolled into a larger narrative. A captured machine taught a nation how to be harder to kill and quicker to mend. The Type A rumor faded, but the lesson hardened into policy. The day the fighters miscalculated was counted later not in single victories, but in the steady decline of enemy capacity, an erosion that begins where machines are repaired and ends when factories stop producing. The tests at Farnborough were a small theatre of truth. They said plainly that industry, more than a siren, decides a long war. The morning the reports land on Griffiths's desk feels like a quiet knock at the gates of certainty. Paper folders slide across blotters, photographs of stamped panels and jig holes stare up like proofs, and the room smells of smoke and old coffee. He reads numbers and measurements, rivet spacing, hole tolerances, stamped supplier codes, and something in him tightens with a mix of admiration and alarm. This is not the work of lone masters, he says to the men around him, fingers tapping a drawing as if to puncture the paper. Outside, the airfield coughs with tractors and the distant rumble of convoys that must bring parts and tools. The war has become a problem of factories, not only of courage. Griffiths walks the workshops where men still prize hand skill, and he hears their pride in careful fitting and final shaping. We learn a joint by feel, an old fitter tells him, voice rough as a rasp, and his hands show the memory of years at the file. Yet the Lancaster's skin answers differently. Identical panels, the same countersink, the same nutplate in the same place. Repeatability stamped with dies, not coaxed by eye. The contrast lands with a physical thud. Craft is noble, but systems make whole squadrons. Gratitude for artisans becomes a sober question. How to marry the craftsman's eye to the press's speed? They map the chain, and the map looks like a spider web of suppliers. Press shops, gear grinders, stamping dies, galvanizers, small firms whose names sit on metal tags. To copy a drawing is one thing. To clone a supplier network that mills hub after hub to the same spec in the same hour is another. Griffiths pins supplier codes on corkboards and sees a geography of dependence. Towns that make jigs, pockets of machine shops with key grinders, foundries with specific heat treatment recipes. We cannot snap our fingers and make that river flow, he tells a meeting, and the room hears how production is a landscape you must shape over time. They tally shortages that are not romantic. Machine tools in scarce supply, trained toolmakers drafted to arms, alloys rationed like sugar. A turret of presses sits idle because a particular die feed is delayed by a rail line blown in the last raid. Men who work in heat treatments explain how a steel that will stand turbocharger stress must be melted and cooled in ways a small shop cannot afford. Turbometallurgy, they say plainly, is not a formula you scrawl on a pad. It is ovens, experience, and time. The sobering truth, talent without kit is a promise unkept. Automated riveting machines and drill jigs leave their signatures in a way a hand never can. Uniformity. The auditors show young engineers a hole pattern, and the cadets gasp. 6 holes. Dead even, each to the 1,000th. Such patterns are not artifacts of genius, but of investment. Jigs that bite, long production runs that amortize the cost of a die, and inspection systems that refuse to accept variance, Where one shop fitted and trimmed, another pressed and fitted millions into the same geometry. The strategic advantage sits not in the blueprint, but in the assembly line that repeats it. Griffiths and Sir Alan Brooke translate these technical notes into strategy memos with a tone of strict arithmetic. A design alone does not deter raids, Brooke writes in a memo that will rattle ministry desks. It is the ability to replace and repair with speed. They sketch timetables, turnaround times at depots, days to replace a wing panel, hours to swap a supercharger housing, and the raw numbers settle like verdicts. The RAF can fight planes. An industrial rival can fight fleets. The calculus of attrition shifts from isolated heroics to the steadier problem of sustaining presence. The men in the factory lines respond in practical humility. Foremen retool bays, order grinders, press for more jigs. They teach apprentices to read a die mark like a ledger. "We will learn to run the press," one older manager says, and there is a stubborn joy in the voice. Yet the transformation is a heavy thing. Retooling costs time, and time is an enemy in war. Every extra press bought, every trained hand returned to a bench, is a vote for endurance. The country learns to value repetition as much as innovation. Opponents cannot simply be outdesigned, they must be outsupplied. That is the lesson repeated in quiet rooms. The Lancaster's precedents, interchangeable parts, supplier stamps, inspected tolerances, creates a doctrine of redundancy. Make enough that loss is a number, not a catastrophe. The enemy who counts on precision in the hands cannot easily match a nation that makes precision at scale. Thus, the battlefield becomes an industrial contest, and victory becomes a ledger of parts and hours. Technical limitations sit like blunt rocks in the path when planners try to accelerate their own lines. Foundries need time to develop alloys that resist turbo stress, and heat treatment cycles require furnaces manned by specialists who cannot be conjured overnight. The charm of a drawing vanishes when confronted with the cold math of metallurgy and the caprices of supply chains. Engineers speak of tolerances as prayers. They know prayers do not replace ovens. The structural truth is small and cruel. Technology's promise is tethered to factory capacity. The logics of repair also transform tactics. Where once commanders feared a single lost bomber as a crisis, they now calculate depot turn times and repair curves. They ask different questions. How fast can a wing be swapped? How many replacement engine stands can a depot turn in a week? Strategy becomes a question of logistics rhythm. How often can you sustain pressure before the enemy's supply fractures? The Lancaster audits give answers that turn maps into schedules and maps into supply networks. There is a moral weight to this conversion of craft to capacity. Soldiers and mechanics feel it physically. Hands rubbed raw at night, shifts extended, wives and mothers sewing and riveters creasing palms under lamps. The shift from artisan to assembly is not smooth. It bruises identities and reshapes pride. Yet many men also feel a grim dignity. They are building a system that saves lives by sheer repetition. "We stitch them until they fly," a foreman says, voice tired and proud, and that small sentence becomes a kind of anthem for the mills. Enemy intelligence sees the change and misinterprets in ways that reveal fear and strain. Photographs of assembly yards and stamped panels feed into war rooms and into diaries. Analysts scribble numbers, production rates, part counts, and try to imagine the American and British capacity as a swell they cannot match. The realization gnaws. Even perfect design cannot overcome an opponent whose factories hum day and night, turning blueprints into a flood. The calculation is cold and simple. Quantity, with quality kept above threshold, beats singular brilliance. Sir Alan Brooke captures the mood in briefings where he speaks not of glory, but of systems. "We are not merely making parts," he tells ministers. "We are building the mechanism that will allow our men to be present where it matters." His words carry the authority of a strategist who sees war as more than maneuvers. It is infrastructure. Ministers lean in and budgets begin to move, not toward vaunted prototypes, but toward presses, training schools, and the dull, steady work of inspection. The auditors close their files with a tone that is both sobering and instructive. They know that humiliation can teach faster than victory. The lesson is bitter but useful. Post-war plans are sketched with these hard edges. Invest in jigs, in grinders, in a culture of repeatability, and teach workshops to sing the same note at scale. The humiliation at seeing an enemy's production philosophy mirrored in a single plane becomes the seed of a national reinvention. The cliff hangs open. The immediate fight required rivets and grit, but the long war demanded a transformation of systems. The Lancaster taught Griffiths and Britain a lesson that would echo into laboratories, into classrooms, and into the beating heart of industry. The final thought is sharp and almost gentle. Victory is not the triumph of one brilliant design, but of a system that can crank out good enough, again and again, until numbers, not accidents, decide the sky. The hangar at Farnborough had long since stopped smelling only of oil and hot metal. It began to smell of lessons. Men who once knelt in mud at Ridgewell now stood at benches with clipboards and chalk, turning measurements into rules and rules into plans. They had opened an enemy bomber and found not just iron, but a method, a repeatable, steady logic of dies, jigs, and supplier marks. That discovery sat on the table like a detonator. The shape of victory was industrial, not merely heroic. The noise of presses and the whisper of micrometers became the new music of defence. Group Captain Griffiths folded his reports into briefing files that travelled to Hatfield, Filton, and Manchester like gospel. Engineers read the pages with a new hunger. Apprentices learned the language of tolerances and torque, instead of only the poet's language of fit by eye. Automated riveting jigs and drill templates were no longer curiosities to be feared, but tools to be tamed and taught. Men who had prized the craftsman's touch began to respect the press's bite, because a die that is true makes 1,000 parts that are true. The war had taught them a simple, cold arithmetic. Repeatability saves lives. At Hatfield, the old bays were reorganized into flows and cells, and men drew lines on concrete where once they had only bent metal. Presses were ordered, conveyors laid, and the first automatic riveting heads mounted like mechanical thumbs. Engineers who had measured rivet heads in Farnborough now designed stations that would do the same work faster and the same way each time. Standardized fittings, nut plates, doublers, quick change mounts, moved from notes into racks and manuals, ready for depot hands to use without argument. The air smelled of new oil and of a new kind of faith. Filton took the lesson into heavier metal and longer runs, where stamping dies bit panels and repeatability conquered variants. Men in overalls fed blanks into presses and watched a sheet emerge precisely formed. Inspectors checked countersinks and stamped part numbers like priests reading scripture. The idea that a machine could be trusted to make the same cut again and again spread like a new creed. Tool rooms learned the names of dies and the ways to keep them true. The hum of grinders replaced the solitary hymn of the fitter. Production became choreography, and choreography became power. In Manchester, workshops that once made single pieces now made sequences. Supplier lines synchronized, delivery schedules tightened, and small firms learned to speak in batch sizes. The old model of artisan independence bent under the logic of integration. One firm would stamp, another would drill, another would heat treat, and the part would arrive at the final assembly like a solved puzzle. Engineers mapped supplier networks as landscapes, and procurement became a strategic act as vital as design. The Lancasters' stamped codes had taught them that the strength of a fleet lives in its supply chain. In classrooms at Farnborough, the case of the Lancaster entered the curriculum like a stern professor. Hugh Dowding's and Sir Alan Brooke's essays on systems thinking were read aloud, not as abstractions, but as commands. Organize, standardize, inspect. Young engineers learned to pair the drawing board with the shop floor, to write specs that workshops could meet 1,000 times. Not the best single machine, a lecturer would say, voice low and firm, but the best producible system wins wars. The phrase sank into notebooks like a law. Former test pilots taught a different lesson. how a machine behaves after punishment and repair. Wing Commander Foster recounted landings with throttles uneven, autopilots humming corrections, and the feeling of a frame that could be patched and flown again. Students learned to value redundancy and accessible mounts, and to see armor plates and doublers as not merely strength, but as time bought for a crew. "If she gets you home," Foster said in the mess, "that's the design's headline." The pilot's stories made the factory's numbers human. The RA's reports, once technical and dry, became blueprints for post-war industry. The ministry funded presses and training schools. Jigs were ordered, apprentices multiplied, and inspection regimes tightened. The nation poured money not just into prototypes, but into the muscle that would make them in volume. The lesson of a captured bomber hardened into policy: scale the good practices, and you change the balance of risk in war. Men in suits and men with oily hands shook hands across benches and agreed to a new world. Beyond industry, the Lancaster's legacy seeded education and management. Universities taught quality control and production flow. Engineers who had measured rivets now lectured on statistical process control and tolerances. The practical arts of stamping and presswork fed early studies in automation and later composites. The case of a single bomber, opened, measured, and understood, became a textbook chapter that would shape curricula for decades. Students learned that precision on the bench echoes in the theatre of war. There was humility in the transformation. Craftsmen did not vanish. They adapted. Master fitters became supervisors of cells, teaching apprentices how to feed a press or check a die rather than shaping a wing by eye alone. The artisan's eye found new dignity in quality control, and the old pride in a hand-filed edge became pride in a line of parts that matched. Men who had once scorned the press now understood the virtue of sameness. The change was hard and sometimes bitter, but it worked. Post-war firms, those that would become household names, grew from these seeds. The discipline of supplier integration and stamping found civilian application. Cars with bodies cut true by dies, household goods stamped in mills, electronics mounted on boards made repeatable by jigs. Techniques born of urgency in wartime became the bedrock of peacetime industry. The world would later learn from these methods in ways the wartime men had imagined only dimly. Ex-test pilots and engineers carried the Lancaster story into memoirs and lecture halls, and their words were both confession and instruction. "She was a hard teacher," one wrote. "She taught us to trust the press more than the hand." Those accounts fed a culture that prized systems thinking and manufacturing discipline, and the baton passed from one generation to the next. The bomber that had been enemy now raised voices that argued for planning and process as the engines of national power. In dingy rooms and in warm auditoria, the moral settled. Organization, not genius alone, shapes destiny. Sir Alan Brooke's memos, Hugh Dowding's reflections, Griffith's notebooks. These were not trophies, but tools. Their lessons stitched into policy and into the architecture of factories, and the nation's ability to sustain presence in the air improved in measurable, tragic ways. The Lancaster had been a blunt teacher. Its lesson was surgical. Years later, a young engineer at Hatfield would point to a drawing in a company brochure and say, "We learned this from the Lancaster." He would mean the part numbers, the supplier codes, the insistence on repeatability. The industrial heartbeat had shifted. Where once bespoke made pride, now repeatable made survival. Men who had once bent metal by eye were now architects of flows, and their children built machines for peace with the same exacting temper. Finally, in a quiet hall under museum lights, a Lancaster rests with Merlins hushed and skin polished. A maintenance stand holds a clipboard from Griffith's, its pages yellowed and full of measured notes. Visitors move in slow circles, reading captions that tell of rivet patterns and supply chains, unaware perhaps of the nights of cold hands and the slow change those nights begot. A child points, and an old man, with grease in his memory, smiles without words. The last line is simple and blunt. The plane that had once been a thunderbolt of the enemy became a teacher of industry. And the lesson it taught was this: organization, not the flash of solitary genius, decides the long war. The Lancaster's ribs keep that lesson like an archive. And the world that rose from those measurements learned to build fleets that could not be outmade by a single bravado. The machine went quiet, but the system it revealed kept humming into the future.